Picture a dark, futuristic space. Suddenly, tiny glowing digital particles start gathering, right? They're forming neural networks, rapidly expanding and connecting until they create this massive, brilliant brain made entirely of light. Welcome to This Explainer. Today, we're tracing one of the most wild technological awakenings in human history. We're looking at the complete evolution of artificial intelligence, from a basic text predictor into a massive autonomous digital workforce. Okay, let's dive into this. First, the birth of the transformer. Second, the mainstream chat revolution. Third, seeing and hearing reality. Number 4, AI learns to think. And finally, the autonomous digital workforce. I want you to anchor yourself in this incredibly rapid timeline. Just look at how fast we're moving here. We start back in 2018 with generative pre-training, basically primitive computer terminals generating simple text. And then, in less than a decade, we arrive at 2026, where we've got these futuristic AI ecosystems running global workflows all on their own. It is an absolute exponential curve of capability. Section 1. The birth of the transformer, the foundation of modern AI. So early on, researchers made this stunning discovery. Scale itself actually improves intelligence. Literally just making the model bigger makes it smarter. We started with GPT-1, which was built on a decoder-only architecture. Now, it was tiny by today's standards, just 117 million parameters, with a highly restricted total instruction set that was limited entirely to basic text prediction. Then came GPT-2 in 2019, and that expanded rapidly to 1.5 billion parameters. It had a slightly broader instruction set, which allowed the neural network to actually string together long, coherent paragraphs without losing the plot. But then, by 2020, GPT-3 absolutely exploded onto the scene with a massive 175 billion parameters. And what's so fascinating is that as the nodes grew, these totally new, unprogrammed capabilities just naturally started to emerge. Under the hood, the total instruction set was undergoing a fundamental transformation. With GPT-1, your context window was just a few hundred tokens. I mean, that's barely enough to remember a short paragraph. GPT-2 pushed that limit to 1,024 tokens. But GPT-3? That is where the instruction set vastly expanded. The context window doubled to up to 4,000 tokens, and they introduced this concept called few-shot learning. This was a real game changer, because instead of having to retrain the entire model from scratch for every single new task, the expanded instruction set meant you could just show it a few examples right there in your prompt, and it would learn the pattern instantly. It completely shifted the AI from just finishing your sentences to actually doing strong code generation. When we compare these first 3 generations side by side, the exponential leap is just staggering. Look at GPT-1 and GPT-2. They were virtually incapable of logical deduction, with 0 to maybe very basic coding ability. But then GPT-3 jumps right to basic to good programming skills. Its reasoning goes from very basic to moderate. The main innovation here completely transitions from just figuring out how to generate large chunks of text to actually mastering that few-shot learning and basic problem solving. But, despite all of this raw computational power, it still wasn't a true back-and-forth conversational assistant that you could just naturally talk to. Section 2. The mainstream chat revolution, the RLHF breakthrough. Now, what's really interesting about this slide is how it highlights the solution to the biggest problem in early AI. See, older models just blindly predicted the next word. The core technical innovation that cured that was RLHF, reinforcement learning from human feedback. Basically, humans ranked the outputs, trained a reward model, and used reinforcement learning to literally force the AI to act helpful, aligned, and conversational, rather than just endlessly guessing the next word. This alignment process is exactly what created GPT 3.5, which is the engine that powered the original ChatGPT we all remember. Technically speaking, this was a massive leap because the total instruction set was completely overhauled. It started prioritizing following your instructions over mere text prediction. The context window expanded huge, up to 16,000 tokens, which finally gave it a really solid working memory for back-and-forth dialogue. And why this matters is simple. It added dialogue tuning, intricate safety alignment layers, and refusal systems to stop harmful outputs. The AI was finally following user instructions with strong precision, formatting its responses beautifully and actually maintaining context within the chat session. It literally transformed the technology from a niche researcher sandbox into an accessible, highly capable assistant for the entire world. Contrasting this with its predecessor reveals the exact leap that changed the world. GPT-3 possessed only moderate instruction following and absolutely zero memory handling between your prompts. Every prompt was a blank slate. GPT 3.5 upgrades that instruction following to strong, introduces highly effective session-only memory, and expands the context window significantly. It's exactly this specific combination, the rapid processing speed, the dynamic contextual memory, and that careful human alignment that truly sparked the mainstream chat revolution. It turned a raw algorithm into an everyday tool for all of us. Section 3. Seeing and Hearing Reality. The Multimodal Shift. The technical specs of GPT-4 and GPT-4o are absolutely mind-blowing. GPT-4 introduced this massive mixture of experts routing system. That means it wasn't just one monolithic network anymore. It was specialized subnetworks dynamically collaborating behind the scenes. And the context window? It exploded to 8,000, then 32,000, and all the way up to 128,000 tokens with GPT-4 Turbo. We're talking about processing entire books at once. But the true paradigm shift was GPT-4o, the Omni model. See, older systems used a clunky pipeline. They'd convert your speech to text, process the text, and then convert it back to speech. GPT-4o became natively multimodal. Its total instruction set was fundamentally rewritten to process holographic equations, images, and human voices directly in one shared representation space. This completely eliminated that awkward robotic latency, unlocking real-time interactions, subtle emotion detection, and lightning-fast communication. It literally gave the digital brain eyes and ears. When we compare the capabilities here, the difference is just night and day. GPT 3.5 had absolutely no multimodal abilities, none. GPT-4 introduced partial vision using separate encoders, but GPT-4o, that is natively multimodal. On top of that, the reasoning capability jumps from moderate to strong, and the processing speed goes from just fast to virtually instantaneous. By natively understanding rich audio and high-resolution visual data directly, GPT-4o entirely leaves the text-only, session-based models of the past in the dust. It creates this incredibly fluid conversational experience. Section 4. AI learns to think. Deliberate reasoning architectures. So models like O1 and O3 completely abandon that immediate next token generation we were just talking about. Instead of just blurting out an answer, the AI now utilizes a massive new total instruction set dedicated entirely to generating extended reasoning traces. The internal cognitive workflow is just fascinating. First, it engages in multi-step planning. It essentially builds these glowing internal logic trees. Then, it uses hidden reflection loops to double-check its own logic, and it executes self-verification to catch mathematical errors or hallucinations before they ever reach you, the user. This simulated deeper cognitive workflow unlocked expert-level scientific analysis, complex mathematical proofs, and advanced code debugging. Instead of just trying to sound human, the AI actually learned to think through a problem step by step. This fundamentally shifted its role from a simple communicator to a highly advanced problem solver, capable of tackling tasks that previously required PhD-level human experts. The transition from GPT-4o to GPT-5 marks a massive architectural pivot. While GPT-4o is highly optimized for real-time, rapid-fire multimodal interaction, GPT-5 evolved into a comprehensive, system-based model. It utilizes an advanced dynamic routing system that intelligently chooses between fast inference for simple questions and a deep, deliberate reasoning engine for the really complex tasks. It pairs this with hundreds of thousands of tokens of context and highly autonomous tool usage. It perfectly blends the best of incredible speed with deep, deliberate thought. Let's move to and see how this builds into Section 5, the Autonomous Digital Workforce, the GPT 5.5 ecosystem. 1 million. I really want to let this colossal technical spec sink in for a second. GPT 5.5 features an API context window of up to 1 million tokens and a codex context of 400,000 tokens. This unprecedented capacity allows the AI to ingest massive enterprise data sets, entire libraries of financial records, or massive software repositories all at a single glance. It's absolutely wild. And because it can hold so much context, GPT 5.5 is built entirely on an agentic architecture. It doesn't just answer your questions anymore. It actually completes long-running workflows. Its total instruction set is highly autonomous, allowing it to plan, inspect its own results, retry failures, and verify outputs completely independently. It uses a mixture of systems routing to dynamically juggle specialized models, which drastically reduces compute waste. Plus, it features deep tool integration, meaning it seamlessly operates web browsers, coding environments, and software interfaces.
Co-designed alongside NVIDIA's GB200 and GB300 Blackwell systems, this model behaves as a persistent, contextual, enterprise-grade AI operating assistant that can manage complex, multi-day tasks without any human intervention at all.
Comparing the 5th generation to the 5.5 ecosystem reveals the true arrival of the autonomous agent. We leap from hundreds of thousands of tokens of context directly up to that 1 million mark. The autonomous workflow capability transforms from strong to very strong, meaning it requires almost zero human oversight. And its coding ability? It crosses the threshold into near expert, enterprise-grade levels. It represents a massive, foundational leap in autonomous, end-to-end task execution. It's essentially replacing entire software suites with a single, highly capable digital worker. And that brings us to the reality we live in today. From text prediction to intelligent digital workforce, the future of AI has arrived. We have literally zoomed out from a single primitive neural network to this glowing digital AI ecosystem that surrounds and supports almost every aspect of our daily lives. Which leaves you with this crucial thought to take away from our explainer today. As this technology transitions from a simple tool that helps you write emails to an autonomous agent that actually does the heavy lifting for you, what does an autonomous AI mean for your daily workflow? Think about it. Thanks so much for joining me.